let's get into it. So, at my day job is I'm the global head of AI at EY, one of the big four consulting firms around the world. And we've been working with Gen AI since it came out. And we have built the world's largest private secure generative AI environment. I have to say that. And we have about 300,000 people on that environment every day. So we started about a year and a half ago building what we called skills at the time. And really, what those are simple agents. So we just decided that we were going to drop the name skills and go to agents for everything that we're building. So we've been building simple agents for a year, year and a half, well, probably just over a year, I guess, at this point. So what does a simple agent actually do? Let's talk about these bullet points, and then I'll give you an example of a simple agent that we've built. They act on a defined action. You want them to do something. In the example we're going to talk about is it builds a proposal for an account team. It can be multi-step. You can have it do 1, 2, 3, 4, 5 steps, but most of the simple agents that I see right now are single step. You prompt it to do something and it comes back and delivers it. And there's some other things that go on behind the scenes. They usually leverage one large language model or small language model or domain language model. Maybe we can get some reaction to this. How many people out there are hearing the terminology small language model and domain language model? They're interchangeable at this point, but they are coming into fashion. I guess they are into practice is one way to say it. We've built our own small language model or domain language model, so we're basing agents on that. And of course, we use models from OpenAI and Anthropic and Cohere and all the large players out there as well. But simple agents usually use one single model behind it. And the prompting is usually pretty straightforward, reasonably straightforward anyway. And as I said, focused on an objective. So let me give you an example of a simple agent. At EY, we've built one called Deal and Delivery Assist. As everybody can understand, organizations want to sell their services, their products, their offerings. And most companies, to sell those, they have to generate proposals. Pretty common activity. So what we did is we built a proposal generation engine. That's the Deal and Delivery Assist. We called it a skill, and now we've redeveloped it into an agent, a simple agent. So what we did is we took a RAG architecture, we took thousands of proposals, we put them in the environment, and we tested it, and we found out it didn't work very well. And the reason it didn't work very well is because we put all sorts of proposals in there, good ones, bad ones, ones that won business, ones that didn't win. And we looked at it and said, well, it's pretty much like any other environment that we build. We need to really build it with the best proposals we possibly could. So we went back and did a human in the loop exercise, and we evaluated the proposals, and we made sure that we only included the best ones out there. So now we have that simple agent out there, Deal and Delivery Assist, and it's working in the United States. And from what I can tell, the last time we measured it, about 70% of the people in EY who could use it have used it. So the idea was that it took multiple people and multiple months to generate an initial proposal. So Deal and Delivery Assist, you come in, you answer a few questions, you hit go, and you get an initial proposal in about 5 minutes, maybe 4 or 5 minutes. So we took a process that took multiple people, multiple months to get to an initial state, and we cut that down to one person in just a few minutes. So, agents can be as simple as that. You're pulling information from different places, you're generating a proposal, and there it goes. So that's where we are, pretty much the state of the art right now. But there's a lot of activity going on in the marketplace, and we have a lot of activity going on in EY specifically, where we're building intelligent agents. So, intelligent agents, let's walk through the bullet points here. They're usually multi step. You would think so with intelligence, and not a single step usually. It's multi agent. So, you can have an agent that's actually acting like an orchestrator for a variety of other agents that are behind it. So, you could have, a large language model like GPT-4o or 1 or you know, Anthropic or Mistral Large, any of those larger models work pretty well as orchestrators. So you could have an orchestrator there. You have your prompt come in, it's torn apart in different ways because that model has been fine tuned on the models that are behind it. So then the prompt is torn apart and sent to the other agents or the other models, and then comes back. So it's multi-step, it's multi-agent, it leverages more than one large language model and maybe a small language model or domain language model that you built. We built one around tax, which was interesting for EY since we have a rather large tax practice. And prompting can be very, very simple. Give me, excuse me, I have to take a swallow. Give me the tax code for non-governmental agencies as it applies to accruing capital expenditures in northern India. That could be a prompt that would be torn apart by the orchestrator. It would be sent into the other models and agents and processes and brought back out, and you get an answer there. That's fairly simple to understand, or it could be very complex. It could be multi-step reasoning in an intelligent agent. You could say something like, I want an economic analysis of the AI spending in the EU area for the next 10 years. And with that forecast, I want you to break it down by country and industrial sector to tell me which of these sectors are going to most likely invest in AI for industrial automation, for discrete manufacturing. And it could go on and on and on. And it could be very, very complex. And the agent would go out and work on that and bring that to you and show you what they have at some point or what it has at some point. Another thing that's interesting about agents is that they can in the intelligent area, they can auto scale. So an agent could look at itself and say, okay, I'm working on this process. I expect that I project, I forecast that I'll have an answer in 4 or 5 minutes, or maybe 4 or 5 hours, or 4 or 5 days, whatever it is. But the agent also has an objective when it's supposed to get the job done. So if the agent says, I project it's going to take me 24 hours to do this process, and it really could take that long, but I need to get it done in 6, I'm going to clone myself 5 times and I'm going to work on it in parallel. I'm going to break the work down. I'm going to send off the EU work to this agent cluster. I'm going to send the US work off to this. I'm going to send the Asia work off to this. Then I'm going to bring it back together and collect it and give it back to you. One of the things that I don't put on this slide, or I didn't put on this slide because it seems to me like it's almost table stakes, that maybe I'm considering too obvious. But at the intelligent agent environment, what the agents are also doing is that they are monitoring the internal and external environment. They're watching, maybe stock market levels or governmental agencies or different business performance metrics or customer complaints for a certain level of severity. It could be monitoring all sorts of internal, external, and then public information, and agents themselves, at least intelligent agents, can proactively work on your behalf. Now, that point alone brings up some interesting ideas. You know, if an agent is working on your behalf, do you want that agent spending your money? And if they are going to spend money, which they certainly can do, you may want to put limits on it. It can spend $10, or it can spend 10,000, or it can spend 1 million. The other thing that you want to think about in intelligent agents too is that they can be rather costly. So, if they're auto scaling and you think that it's going to be one instance of an agent running and it clones itself 10 times, well, your hosting costs and your compute charges are going to be probably 10 to 15 to 20 times larger. Are you ready for that? So, one of the interesting things that I talk about with people when they ask me about agents is that I don't like it when people anthropomorphize or talk about Gen AI as if it's a person. They use pronouns to refer to it and they say this or that. The, generative AI is not a person. It does not have emotions. It does not think. It's not AGI in any sense of the imagination. But what I do say is that the easiest way for people to get a frame around how to treat agents is to think that an agent could do anything a person can do. So what does that mean? An agent needs to be trained. You need to give it all the training material that you would give to a person that's going to operate in a specific area. You need to govern it with all the policies that make sense. They're not people, of course, but you have to understand HR policies and ethics and training requirements and different geographic regulations and things of that nature. So agents need to have a governance framework wrapped around them so they can actually be controlled and governed. So it's quite intriguing. We're spending a lot of time. Simple agents have been very successful. Intelligent agents in the early stages looks like they'll be as successful or more. But I think the governance is going to have to come along rather quickly, because these things could be problematic. We've all seen the stories. There was a Canadian airline that the agent gave a free airfare to, or a very cheap airfare. There's all, I think somebody got a free car or something like that. So the stories are all over the place on what agents can do, and companies have to either live up to those promises, or refute them in some way. All right, let's take a next step forward. We spent a lot of time on intelligent agents, but I think that's time well spent in our conversation. So the next step is what we're calling polymorphic agents. And polymorphic agents can do everything that a simple agent can do, everything that an intelligent agent can do. The interesting thing about polymorphic agents is that they can clearly understand the objectives. They do planning, they do scheduling, they do scaling, they do all those kind of things. But what's really interesting to me is that a polymorphic agent can look at all the other components, the skills, the simple agents, the intelligent agents. It can examine all of those individual pieces and workflows, and it can look at the objective that it's been given, and it can say, the I have 3 steps. Let's say that a development team built the first 3 steps of a process, but that's where they stopped. But the objective that the agent needs to achieve needs another 4 steps of processing. Maybe it needs 6, maybe it needs 10. But what happens is the polymorphic agent looks at what it has, what's been built by people, what's been given to it. It looks at the objective, then it starts extending forward. It says, okay, I got 3 steps. I need another step to bring together external information and integrate it together. And then after that, I have to do a market forecast, or I have to project something, or I have to look for more information. So what it does is then it keeps adding more steps, and it can go back and look at the existing agents and the existing, easy for me to say, existing skills. It can clone those, bring them in, and snap them into the process. So now what we have in polymorphic agents is the beginning of agents building agents in an autonomous way. So it's very intriguing that you can have this library of building blocks and skills and simple agents and intelligent agents and polymorphic agents. And they all start looking at different parts and saying, well, I don't need to build the ability to go do this forecast because it's here as part of this other agent. So I'll just take that, I'll copy it, I'll bring it into my workflow, and I'll snap it into place, and then I'll continue to build. And at some point, what happens is that you started with the 3 human steps that were built, and then you have the other 10 agent steps that were built. And the agent keeps running through the process and comparing the end result with the ultimate objective. And it says, hey, I've met the objective. I've done all the things that I've been asked to do. I've produced all the forecast. I've generated all this new information. I've created a proposal. I've, written this, I've written that, and here's the complete output, the objective, and I deliver it to my end users. So what we end up with is an agent that can actually build processes, steps, skills, and complete agents in an autonomous manner, which is exceedingly exciting to someone like me, because I've been looking at this stuff for decades, and I'm like, when are we going to get to a point of when these things can start actually taking care of some of the work, some of the foundational work that we need to do? And we're there.